your talk is, I found. So the next talk is by Paul Strohmeier from Saarland University, and the talk title is Sketching on-body interactions using Piezo-Resistive Kinesiology tape.
A little helper.
Yeah.
Okay, sorry.
Anytime you can start.
Okay, start in a moment. I'm just going to hand this little friend over.
Yes.
Cool. Sorry for delays. It's been an interesting week, and it's only Tuesday. Okay, so let's see. How do I share the screen? Share screen. Share. And here's my presentation. Perfect. So hello, everyone. As Shoya said, my name's Paul. And one of the things I've been playing with a lot, mainly with some people from a hackerspace in Paris called Datapaulette, is finding out how to make materials piezo-resistive. And piezo-resistivity is super valuable for us because it allows us to create textiles which change the resistance as they are deformed, and this allows for really cool, interactive, soft, wearable sensors. And together with some friends, we all came together at Saarland University, and we developed a method which is really easy for making any material piezo-resistive. What you see here is a paper that we should be presenting at CHI, whatever that means. And that's not the paper I'm presenting now, but we'll get back to that. The paper I'm presenting is called Sketching On-Body Interactions Using Piezo-Resistive Kinesiology Tape. It's work that I did together with Najes Pushafarian, Marion Kölle, Cedric Connet, Bruno Frouchard, and Jürgen Steimle. And we're from the Human Computer Interaction Lab at Saarland University, which is part of the Saarland Informatics campus. And we're funded by the European Research Council. So I was talking about being able to turn almost any material into a piezo-resistive material. And one of the things which we can turn piezo-resistive by polymerization is kinesiology tape. And the cool thing about kinesiology tape is it adjusts to your body. It has the same flexibility as your body. It comes with biocompatible glue. You don't need to worry about how to attach it to your body. You can just cut it out and slap it onto your body. And once it's on your body, you can use it as sensor. So this is Najes demoing that you can very easily turn this into a slider, for example. And not only can you turn it into a slider, you can turn it into a slider anywhere on your body. So here you see the slider on an ankle and on the neck. And because we have this really nice material, which is super easy to work with, you can just slap it on wherever you want it and just very quickly test some things. So we call this rapid on-skin prototyping. And what we're suggesting is if you polymerize this kinesiology tape, you can build on-skin sensors really, really fast. You can iterate really fast. You can throw them out, and you can just explore what it means to have an on-skin sensor. And there's various ways in which kinesiology tape is just super cool for doing this type of exploration. Apologies. No, I'm plugged into power now. What I was saying, there's various ways in which kinesiology tape is really cool for exploring things on the body. For example, in these pictures, on the left-hand side of the ankle, we cut this out circular. So we cut a circle and then put it on the ankle. On the right-hand side, we cut a straight strip, and we could adjust it to shape and follow the contours of the body because the kinesiology tape is so elastic. Other fun things you can do is you can actually go in and modify things. So typically, if you build an on-skin system, you attach it to your skin and then it's there. But kinesiology tape has this affordance of being able to move it slightly. In this case, what I'm showing here, we took this really long sensor, we cut it, and we turned it into two sensors. So you have some space for improvising. You don't need to plan in advance. You can just kind of try things out on the spot. And of course, you don't only need to use piezo-resistive tape. You can also combine it with just regular non-conductive tape. In the top example here, I've built a slider which has kind of passive haptic feedback indicating different zones to me as I slide over it. The bottom slider has discrete zones where it's interactive and other zones where it's not interactive. So you can like play with these affordances of tape and play with what kind of things you can put on your body. Going even more crazy, of course, well, crazy. Let's say you want to attach something else to your body. Kinesiology tape does that too. I showed a slider, but sliders aren't the only thing you can do with piezo-resistive tape. So you can actually apply tape to the body to measure body motion. You can build pressure sensors. You can even make some type of primitive gesture sensor. So I should say here, you see that the mapping between the movement of the cursor and the movement of the finger aren't very exact, but they're repeatable. So you can have an algorithm that classifies gestures, and you can use that for gesture input on the skin. And you can just have regular touch sensors. To get this working, there's a series of, you could call it hacks, you could call it limitations, you could call it contributions if you wanted to, just like weird things we did to make this stuff work. Because the resistance of the kinesiology tape that we used is relatively similar to the resistance of the skin, so weird electronic artifacts start happening, and you can't always do things the way you usually would do them. Another issue is that most resistive sensors have some kind of mechanical structure, a layering of materials. And because we want things to be really quick and dirty and just slap it on, we had to find workarounds for that. And I did some sleight of hand here earlier. In many of the examples I showed you, the person interacting with the tape had their finger connected to an electric circuit. Specifically, we connect the finger to an analog input. And then, for example, to detect touch, we can have multiple touch pads which are all grounded, and we sequentially pull the touch pads high, and the finger that is touching the touch pad measures whether the touch pad is being pulled high or not, and can detect which pad is being touched based on the timing of the pull-ups. Similarly, the slider that I showed at the very beginning, we apply a voltage gradient to the slider, and we measure the voltage with the finger that is touching it. And the voltage that the finger measures is proportional to its position relative to ground and plus, which typically would, in kind of commercial sensors, you would have a multi-layer setup which does this for you, so you don't need to connect the body. But this actually works really well, so I don't mind connecting the body. The gesture sensor that I was showing works by having all edges connected to pins of a microcontroller. And here you can do something cool because you have high impedance pins. You can pull a pin low or you can pull a pin high. You can first attach a gradient horizontally and measure one position. Sorry. So in step one, you attach the gradient horizontally, get one position. Step two, you change the function of the microcontroller pins so that the gradient is applied in the other direction, and then you get a second position. What's really interesting about this changing the function of the pins is it actually allows you to apply a kinesiology tape patch to your body and connecting it to the microcontroller. And afterwards deciding, am I going to use this as a stretch sensor? Am I going to use this as a position sensor? Do I want pressure input? Because the difference between these circuits is merely how the pins are configured, which can all be done in software. In hardware, they're basically equivalent. So if anybody listened to Casper's keynote in the morning, this is what he would call constructivist research. We're trying to find ways of building stuff. And I guess it's also showing ways of prototyping stuff, not only building stuff. And this is only worth something to the community if others know how to do it too. So do you see the website? So what we did is we have a website here, counterchemists.github.io, where we're collecting all different papers that we've written using polymerization. So if you want to do this, check out this website. We have a lot of information online. And that's my talk. Thank you very much for listening. I'm happy to take questions now if there are any.